Everybody's looking for answers to the mysteries of the universe. Our universe is a place of profound mystery and breathtaking beauty. From the smallest atoms to the largest galaxies, a cosmic dance of creation and destruction unfolds across billions of years. At the heart of this grand spectacle lies the birth of planets, celestial bodies sculpted from the remnants of stars long gone. Our own planet, Earth, is a testament to this awe-inspiring process, a testament to the universe's boundless capacity to create. Imagine, if you will, a time before time, a place before space, a point of infinite density, containing all the matter and energy that would one day make up everything we know. This was the singularity, the seed from which our universe sprang forth in a cataclysmic event we call the Big Bang. It's a concept that stretches the limits of human comprehension, yet its echoes resonate within every atom, every star, every planet that graces the cosmos. Our journey begins here at the dawn of time, where the universe was a maelstrom of unimaginable heat and energy. From this chaotic inferno, the building blocks of matter emerged, setting the stage for a cosmic drama billions of years in the making. This is the story of how, from the ashes of the Big Bang, our Earth was born, a tiny oasis of life in the vast cosmic desert. The universe began not with a bang, as the name might suggest, but with an expansion. Imagine a balloon being inflated, its surface rapidly stretching outwards. That's a simplified way to picture the Big Bang. Space itself was expanding, carrying with it a primordial soup of energy and subatomic particles. As the universe expanded, it cooled, allowing energy to condense into matter. This marked the birth of the first fundamental particles, quarks, electrons, and their antimatter counterparts. These particles interacted with each other, annihilating in bursts of energy and reforming as the universe continued its rapid expansion. Within the first second after the Big Bang, the universe had grown exponentially. Temperatures dropped dramatically, allowing for the formation of protons and neutrons, the building blocks of atomic nuclei. This was a pivotal moment in the universe's history, setting the stage for the creation of the elements that would eventually make up stars, galaxies, and even ourselves. Roughly 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Electrons, once free-ranging, were captured by the nuclei of hydrogen and helium, the simplest and most abundant elements in the cosmos. This event, known as recombination, had a profound effect. It allowed light to travel freely through the universe for the first time. The universe, once a glowing fog of charged particles, became transparent. This first light, now stretched and cooled over billions of years, is still detectable today. We call it the cosmic microwave background radiation, a faint afterglow of the Big Bang, a whisper from the universe's infancy. This faint radiation, picked up by sensitive telescopes, provides a snapshot of the early universe. It reveals tiny fluctuations in temperature and density, the seeds of what would become the large-scale structures we observe today: galaxies, clusters of galaxies, and vast cosmic voids. Fast forward billions of years, gravity, the architect of the cosmos, had sculpted vast clouds of hydrogen and helium into galaxies. Within these galaxies, denser regions of gas and dust began to collapse under their own weight, swirling and churning, their cores growing hotter and denser. These were stellar nurseries, the birthplaces of stars. Our own solar system formed within one such nebula, a swirling cloud of gas and dust enriched by the remnants of previous generations of stars. This enrichment was crucial as it seeded the nebula with heavier elements like carbon, oxygen, and iron, the very elements that would become the building blocks of planets and eventually life itself. As the nebula contracted, it spun faster and faster, much like a spinning figure skater pulling their arms inward. This spinning motion flattened the cloud into a disk, with most of the material concentrated in the center. At the heart of this swirling disk, a protostar ignited, our very own sun in its infancy. The newborn sun, blazing with youthful energy, bathed the surrounding disk of gas and dust in light and heat. This protoplanetary disk, a cosmic pancake of swirling debris, was the arena where planets would be born. The composition of this disk was far from uniform. Closer to the Sun, where temperatures were higher, only heavier elements and compounds like rock and metal could condense into solid particles. Further out, beyond what we call the frost line, temperatures were low enough for volatile compounds like water, methane, and ammonia to freeze into icy grains. This division of materials played a crucial role in shaping the destiny of planets, dictating their composition and ultimately their fate. Within this swirling disk, tiny grains of dust, no bigger than specks of sand, orbited the young sun. These particles, constantly colliding and sticking together, began a process of aggregation, gradually growing larger over millions of years. As these dust grains clumped together, their gravitational pull increased, attracting more and more material. Pebble-sized objects grew into boulders, then into kilometer-sized planetesimals, the building blocks of planets. These planetesimals, drawn together by gravity, collided in a chaotic ballet, their impacts releasing tremendous energy and heat. Some collisions were destructive, shattering planetesimals back into smaller pieces. But many were constructive, leading to the merging of these planetary embryos into larger and larger bodies. This process, known as accretion, is the driving force behind planet formation, a cosmic game of billiards played out on a grand scale. In the inner solar system, where rocky material dominated, this process gave rise to the terrestrial planets Mercury, Venus, Earth, and Mars. These planets, forged in the heat of the young sun, are characterized by their solid surfaces and relatively small sizes. During its infancy, Earth was a hostile and unforgiving place. The constant bombardment of planetesimals generated intense heat, melting the planet's surface and creating vast oceans of molten rock. This period, known as the Hadean Eon, was a time of intense volcanic activity, with eruptions spewing gases and molten material into the atmosphere. As Earth cooled, a thin crust began to form, only to be repeatedly shattered by impacts. The atmosphere was a toxic mix of carbon dioxide, nitrogen, and water vapor, devoid of the oxygen we breathe today. The oceans, formed from condensed water vapor and delivered by icy comets from the outer solar system, were hot and acidic, yet within this seemingly inhospitable environment, the seeds of life were being sown. The very elements delivered by those ancient impacts, along with the energy from the sun and Earth's internal heat, would provide the raw materials and the spark for life to emerge. Over millions of years, Earth continued to cool and stabilize. The relentless bombardment of planetesimals subsided, allowing the planet's surface to solidify and the oceans to cool. The atmosphere, though still toxic, began to clear as volcanic gases dissolved into the oceans or were locked away in newly forming rocks. This period of relative calm allowed for the emergence of life. The exact details of how life arose from non-living matter remain a mystery, but we know it happened here on Earth, a testament to the universe's remarkable capacity to create complexity and beauty from chaos. The formation of Earth was not merely a cosmic accident, but a culmination of billions of years of cosmic evolution. From the Big Bang to the birth of stars and the accretion of planets, each event played a crucial role in setting the stage for our planet's formation. As we gaze up at the night sky, we are reminded of our place in the grand scheme of things. Earth, a pale blue dot suspended in the vastness of space, is a testament to the awe-inspiring power of the universe and its boundless capacity to surprise and inspire. We are each of us made of star stuff, forged in the hearts of long-dead stars. Our journey began, not on Earth but in the fiery crucible of the Big Bang. Understanding our cosmic origins allows us to appreciate the interconnectedness of all things. It instills in us a sense of wonder and a profound respect for the delicate balance that makes life on Earth possible. The story of Earth's formation is a reminder that we are part of something much larger than ourselves. It's a story that continues to unfold even today, as we explore the cosmos and unravel the mysteries of our universe, one discovery at a time.